All right, now, this is just simultaneous equations. That's it. But it's just, we put it in log clothes and it looks harder, okay? Now, when you look at simultaneous equations, like say if I gave you simple ones, like say this, x minus y equals 3, and I don't know, 2x plus 3y equals 1, okay? What would be a strategy to solve something like this? What would you do? Suppose if I said find x, just forget about y. I know you can find y, but you know. What would you do? I said find x. Years of training has led to this point. Okay, if I want x, I need to eliminate y, right? So I'm going to shift and change these equations in whatever way I need to, so that when I combine them together, you have to combine, that's why it's simultaneous equations. When I combine them, the y's will vanish and I'll be left with the x's, okay? So it's exactly the same deal here. You've got log base a of all this garbage that we need to get rid of, specifically the y's, so I'm left with the log base a of x, okay? So, what am I going to do? I only have to really muck around with one of the equations in order to make it fit the other. Just like here, what would you do? I guess you'd maybe multiply this by 3, then you can just add them, and it would work, right? Well here, if I've got equation 1 and equation 2, it's probably easier, I mean you could take either and it would work. It's probably easier to take 1 and shift this square root of y so that it'll be more like a y squared, okay? And then we can take them out of the wash. So, if I take equation 1, okay, what must I do to equation 1 to change this square root y so it's going to be a y squared? What must I do? Maybe I should rewrite it. This is log base a of x times, and that's y to the power of half, right? And that's equal to 1, okay? Now, I want this half to turn into a 2, yes? Half turns into 2. So what am I going to have to do in here? I'm going to need to have a 4 up there, right? That's a power issue, okay? Because I have to fix up the power. I've got to multiply by 4 to get up to 2, all right? But I can't just, if I'm raising to the power of 4 this bit in here, okay? This x, y to the power of half. Just in case you're curious, and it'll help you describe these functions a little better. This guy in here is called the argument. Has nothing to do with like, I said this, no, you said that kind of thing. It's about what you input into something to make it work, okay? Anyway, I'm raising the argument to the power of 4, not the whole thing, okay? So putting this 4 here doesn't put a 4 there, right? You should be careful. So in fact, what I might do is go a step back. You know your log laws, right? So if I want to power here, a way that I can do that, an equivalent way, is actually by multiplying the whole thing by 4, okay? Because I can move that coefficient up into the power, right? And that's something I can do to the 1 as well, okay? So if I multiply the left-hand side, I'll multiply the right-hand side as well. So now when I bring it up, and go back to the previous line I had, x, y to the half to the power of 4, equals 4. Now I can actually expand out my powers, okay? So I'll get log base a of x to the 4 y squared. Is that okay? And that's equal to 4. Okay? So now that's ready. I've done my shifting and my changing, so now I can put the equations together. So since I got this equation from equation 1, I'm going to call it 1a, just to make sure I don't put it back into the same thing. Okay? So now I've got 1a, and I'm ready to combine it in 2, but what way should I combine it? This is logs, right? And I want this y squared to cancel with this y squared. Okay? So the first thing that comes to mind would be division, right? Because if I divide this y squared by this y squared, it'll cancel, and I'll get my x's, right? But in logs, you might have noticed this is your log laws, right? Division is equivalent to subtraction. Okay? It's the reverse of index laws, okay? So I'm going to take 1a, equation 1a, and I'm going to subtract 2. Is that okay? You could do it the other way around, you just get a double negative, okay? So on the left-hand side, I'm going to have log base a of this guy minus this one here. Same thing, but with an x squared. Okay? And that leaves me with 3 on the right-hand side, 4 minus 1. Okay? Now from here you could probably almost jump straight to the answer, almost, but I'll just put another line just to make it a little more obvious. Here I said subtraction is equivalent to division, right? So this is equal to the log base A of, and this is why I bothered to introduce the word, right? Subtraction of these log terms means division of the arguments, okay? So I'm going to have, this is the first argument, so it's the numerator, and this is the second argument, so it's the denominator, okay? And that's equal to 3. So now my y-squareds cancel just like I wanted. I'll have log base A of x squared, which is equal to 3. And now I can just reverse the trick I had before, which is that now I've got an index, a power on the argument, so I'll bring it up front as the coefficient, right? So this 2, I can just whack out the front, and that's what gives me the actual term that I'm after. Okay, let me see. And if we change the question to be calculate log base A of y, it'd be much the same thing, except in this step here, as I sort of wiggle around with one of the original equations, I would be doing it so that I eliminate x instead of y. That's all. That's the only difference. Okay. So if you're a bit shady with these, you're like, not sure. Use that as a practice question. Have a go at doing log base A of y from scratch. So take an equation, one of them, and manipulate it such that it makes it easier to eliminate the x terms. Okay? Alright, any questions on that?